So here we are with topic 4-1. We're moving into topic 4, talking about rational numbers, opposites, and absolute value. You did talk about this topic last year, so this should not be anything brand new to us. Really, we're just going to review this topic and go forward. If there's anything you never need help on, please go back to your notes first, check over the definitions, and ask me as well. So, for the first vocabulary word we have here is rational numbers. A rational number is a number that can be written in the form a divided by b or negative a divided by b, where a and b are both whole numbers and b is not equal to 0. The reason why b cannot be equal to 0 is if you had, say, 3 divided by 0, that is an undefined number. You can't take 3 and divide it into 0 groups. It's an undefined. There's actually no answer. And if you type it into your calculator, 3 divided by 0, it'll say error. So when I see word rational, I see the word part ratio. And a ratio, again, is a comparison of two numbers, which is what they're showing me right here with a to b. And they're just trying to show that it can be positive or negative. So they say you can also think of the rational numbers as whole numbers, fractions, and decimals you already know, and their opposites. So what they're showing you here is that this whole box, any number that lands inside the rational numbers is an integer and is a whole number. So rational numbers can be written as fractions. They can be positive or negative. They can also be integers, and they can be whole numbers. So they're just showing us many different examples here of what types of rational numbers are. Then we have this other box, I'll put it in red, which is the integers. So what this is saying is that integers are in the set of rational numbers. So a number can be an integer and it can be a rational number. But I want you to notice that an integer, there are some integers that are whole numbers, but not all integers are whole numbers. This is kind of a circle is a square, but a square is not a circle, a rectangle is not a square, but a square is a rectangle. So now we have our whole numbers, and the definition of whole numbers are they're whole. They're not decimals or fractions, and they're all positive. So the first whole number is 0, 1, 2, 3. So if you look at the number, or look at the word whole, you have 0 and 1 right there. So reminding you that whole numbers are 0, 1, 2, 3, and so forth. Integers are the whole numbers and the negatives. Okay? So, I'll say this again. All whole numbers are integers and rational numbers. Some rational numbers are integers or whole numbers. And there are some rational numbers that are neither integers or whole numbers. So what we're going to do on the example number 1 is place these numbers into each set where they belong. On your notes, I don't know why, but the integers box is a little weird. Don't worry about that. So I'd like you to pause the video and just decide where all these numbers belong. Okay, so if you look here, the whole numbers are only the ones that are positive and they're not fractions or decimals. Whole numbers are not fractions or decimals. Really need to make sure we understand the vocabulary. And they're also positive. Your integers are also not fractions or decimals, but they can be positive or negative. And rational numbers can be positive, negative, and be fractions or decimals. So basically, every number that is on the list should be under rational numbers. Question number 2 says, to which set of numbers does -1 and 3/5 belong? It says sets, so that means there could be more than one answer. When you look at this is a fraction, so right off the bat, I know it's not a whole number. It's not an integer because integers are also whole numbers, but positive and negative, so it only belongs to the rational numbers. Question number 3. Go ahead and read that question. Put down your answer. So 4 divided by 4 is a fraction, but when you simplify this fraction, 4 divided by 4 will give you 1, so it does actually belong in all 3 categories. So the other friend, and they didn't do a really good job of classifying them, the other friend is correct, that it does belong in all 3. Now we're going to the vocabulary of absolute value, and this states that the absolute value of a number is its distance from 0 on the number line. The symbol for absolute value of a number n is these little, like, ski poles, I want to say, that go around n. I don't want you to think that the answer is always going to be positive, because they could throw a negative sign somewhere else. If they threw a negative sign on the outside of your absolute value sign, when you take the absolute value, you would get 1 4/10, but then you have to bring that negative down. What they're trying to say right here, when they say distance is always positive, well, that's true. You would never say, guess what, guys, I ran negative 3 5/10 miles last night. That doesn't sound impressive whatsoever. You need to make sure that you are saying a positive number. So absolute value is associated with distance. So they're saying the absolute value of 2 is 2 because it is 2 units away from 0, and the absolute value of negative 1 4/10 is 1 4/10 units from 0. So obviously the negative is just telling us the direction, that it's to the left of 0, and positive is telling us that it's to the right. The negative sign tells us direction. So number 4 is asking us to compare these, all of these with a greater than, oh, that's a less, that is greater than, less than, or equal to sign. What I would like you to do is don't just put down the answers. I would like you to also actually take the absolute value of each number. So negative 5, the absolute value of negative 5 would be 5. The absolute value of 3 would be 3. So 5 is greater than 3. So please go ahead and do that for the remaining 5. Okay? So the only one that I really had to do any type of simplifying was the last one, where I had to change 9/2 to 4 1/2. So go ahead and check your answers over. For number 5, it says, which of these numbers is listed in order from least to greatest? Again, when students try to do these problems without showing work, that's when we usually make careless errors. So please be sure to show your work. I know it seems very simple, but it's also very simple then to make a mistake. So when I want to go through and find the absolute value of all of these numbers. So I would have 1/2, 3/4, and 3. So they're asking me to go from least to greatest. Always go back and check that. So the smaller number, it would actually just be as 1/2, 3/4, and 3. The second one, this is 1, 8, oops, not negative, 8/10. Wow, 8/10 this way. And 1/5, which 1/5 I will change to a decimal, which is 2/10. And I see that obviously 1 is greater than 8/10, so the first list is the one that is ordered from least to greatest. Moving on to the second page, I tried to add to the top here that this is topic 4-1, so that if your notes are not stapled, you can still find that these are notes. So in this box here, it says that you can use positive and negative rational numbers to represent changes in real-world quantities. 2 changes represented by opposites actually result in no change. No change means it's equal to 0. So I know that this seems a little bizarre if you look at the picture, because obviously she has short hair and long hair, but what they're trying to show is that negative 1 3/4, the distance between her shoulder and her hair is negative 1 3/4 if you go to up, and then the opposite change, it will result in no change. If originally your piggy bank starts with nothing in it, you add $10 into it, then you turn around and take that $10 out, now it results in no change, meaning you have no money to start again. Same thing with your temperature. I kind of think about when I set my thermometer in my house. In the morning, when we wake up, it's 68 degrees. Then we are going to raise the temperature. I don't really raise my temperature to 88 degrees in the house, but then back at night, it goes back down to 68. So really, there's no change. So number 6, it's asking us to write a positive or negative number to represent the change described in each situation, and then describe the opposite change in words and with a number. So normally when we write positive numbers, we do not put plus, like a positive sign, but because they're specifically asking us here to write a positive or negative number, we're going to do that. So the situation says you climbed up 7 stairs. Up, that's me thinking of going up, so that's a positive. So the opposite of that, doing that, would be you walked down 7 stairs. So that would be -7. So again, the negative sign is showing the direction of going down. So the next situation, your car used 9 2/10 gallons of gas. We lost 9 2/10 gallons, so that would be -9 2/10. So the opposite would be to fill the tank with 9 2/10 gallons. And that would be a positive 9 2/10. A submarine descends 3/8 miles. So the descends is telling us that it's going down, so that would be negative. The negative sign is showing us our direction. So the submarine ascends 3/8 of a mile would be the opposite. So that's positive 3/8. So again, even the positive is telling me the direction. You win 50 tokens at the arcade. You must be so awesome. And then you would, to do the opposite, you would redeem 50 tokens. So that would be -50. So the following examples are questions that we've taken from the homework that are similar to homework tonight. They are showing us here that the table shows how your friend classified the given number. This is our given number, -25 minus 20. Well, if you remember from last year, if you're looking on the number line and you're at -25, you are subtracting 20. Subtraction tells you to go to the left. So if you go to the left on your number line, another 20, you're going to end up at -45. So this is -45 here. So they're saying, your friend said that -45 is not a whole number. They said that it was an integer, and they said that it was not a rational number. So we need to determine if this is true or not. So is -45 a whole number? No, because there are no negatives with whole numbers. Is it an integer? Yes, because it is not a fraction or decimal. And then if it's an integer, you know it's automatically a rational number. So your friend was incorrect at first. So when it says, what error did your friend make? Your friend did not classify -25 minus 20 as a rational number. Example 8 says, which of these situations can be represented by the opposite of -53? So we're looking to actually describe positive 53. And they will say check all that applies, so it can be more than one answer. Max saved $53. That sounds like a positive. A book was 53 pages longer than you expected. Again, adding on more pages. Julia drove for 53 minutes. That's a positive. And the temperature was -53. Obviously, -53 is not 53. Then they're asking you to describe 2 more situations that can be represented by the opposite of -53. I said that you won $53. You could say you walked up 53 flights of stairs. That's a ton of stairs. I said that the temperature rose 53 degrees. I mean, you could really come up with endless amounts of answers here. Okay? So we'll see you tomorrow in class. Have a great night.